So we've got a polynomial, we've got a root, kind of sounds like yesterday. Okay, with one little difference, right? The root is imaginary. Oh, you had to do it, didn't you, Miss Neal? The root is imaginary. Now here's the thing, you got to know that I'm presenting this, or I'm coming from an angle where you've seen some of this. I know that for all of us, you kind of got to brush up on it, but you've seen this idea of a root, and you've seen this idea of division. But do you realize that you can use division, I'm talking about synthetic division, with an imaginary root? Yes, you can. Yes, you can. You can divide by an imaginary root. You want to try it with me? It's fun in a strange kind of way. Now, if you believe in sort of the fundamental theorem, and basically if you believe in everything that we're doing with polynomials, what I mean is if you believe that x equals I as a root, then you should believe that this is going to come out to be 0. I'm talking about the remainder. So like it should actually divide. How in the world can you divide by something that's imaginary and actually get 0? Well, I'm glad you asked. And I might not be showing you a big surprise. You just got to follow the math. Now, the math would say that you multiply 1 times I. Okay, 1 times I is I. You're not missing something there. Now what? You're supposed to take these numbers and add them, right? Add them. So -2 plus I. Maybe you weren't sure how to show that, but you just literally say -2 plus I. Now, here's the part where we got to focus a little more, because I now have a quantity. I have a quantity. And anytime you have a quantity and you're going to multiply it, you have to like think distributive property. So both of these buggers are going to get multiplied by I. Now, I times -2 is -2I. That's kind of easy. I can just write that. Ready? I times I. I times I. It should kind of sort of catch your attention mathematically, because I times I is I squared. And I squared is something, right? It's -1. I squared is -1. It's kind of the mysterious fact, but it's not that mysterious. It just comes from the idea of the square root of a negative number. But listen, I squared equals -1. You got to make a decision. You got to make a decision if you're going to write I squared right here. Or I tend to like to say, wait a minute, I already know that that I squared is -1, and I like to just write it as -1. How about you? Are you okay with kind of skipping that step? Okay, because I'm back to adding. Now, look, I can actually add 1 and -1. Ooh, nice. I can add those. They cancel. -2I doesn't add to anything, but it comes down. Ready? I times -2I. -2I squared. Now, again, you kind of have to make a decision. I have to admit, I made a decision. I decided to write it this time. But maybe you'll be like, wait a minute, I squared is -1, and -1 times -2. Now, we got to decide how much of this you're going to do in your head. But this is the same as -1, and -2 times -1. I'm not sure about that. I did a lot of like erasing, but how much of that can we do in our head? It worked. You can't make this stuff up. Okay, it actually worked. This is a depressed polynomial, and it is looking rather weird. We need to divide it again. But what do we divide it by? Here's where we have another, you gotta like be aware, okay? We're doing a couple things in one problem. You say, what am I gonna divide by? You didn't give me any more roots. Well, I sort of did, because if you have this imaginary root, you're guaranteed to have this imaginary root. Listen, imaginary roots always come in a plus or minus pair. So if I gave you I really also gave you negative I. Always, always. Imaginary numbers always come in pairs. Listen, you have to divide this thing again because it's basically meaningless in the state that it's in. But it very quickly becomes meaningful when I take my method, 1 times negative I, add those together, negative 2 times negative I. Now, there's no I squareds here, kids. Negative 2 times negative I is just positive 2I. There's no I squareds. There doesn't need to be. Now I started with x to the third. I divided twice. So that means that this guy is now of the degree 1. What I mean is 1x to the 1. Or much more simply, x minus 2. But when I get 1 and I get minus 2, that really represents x minus 2. Sometimes when a problem is simple, we get confused. Try not to get confused. This guy right here is all you have left. All you got to do is set it equal to 0, and we can do that in our sleep because you just get 2. X equals 2. 1, 2, 3. 3 roots, which is, of course, what we expected. You can divide by an imaginary number. Who would have guessed? Actually, you can divide by 2 imaginary numbers. X cubed, 3x squared, 4x, 12. X cubed, 3x squared, 4x, and 12. Plus the roots are given, the given roots are plus or minus 2i. Now, you kind of got to make a decision. I'm getting a sense that a lot of you would want to try this right now. So try it. Maybe it works out. You're a fast learner. Maybe a mistake is made and I can try to redirect you. You kind of only learn this if you try it. So see if you can divide by 2i. If you get a remainder of 0, things are looking good. You must have done it correctly. No doubt this is the sticky step, to take 2i and distribute it. I did see a lot of you write 6i, which is great. That is correct. You also get something known as 4i squared. 2i times 2i is 4i squared. Are you ready to just change that to negative 4? Probably that makes things a little cleaner if you just change it right away. Is there something you're seeing that you're saying, how'd you get that? Because the only other thing I'm going to do is take 6i times 2i, to get 12i squared. 12i squared is the same as negative 12. Thinking about I squared being negative 1. Did you keep going? Did you keep going? Did you divide by negative 2i? And how about if you got to the very, very end, did you solve your depressed polynomial? Very good. I'll tell you what, you got some good stuff here. Wow, okay. Sometimes people sort of notice or wonder, does it always work this way? Like how things seem to cancel out. Well, yes, it does actually. If the problem was a little bigger, you would have a few more steps in between, but basically things are going to cancel out if that's kind of what you see, so that you can get down to, again, a simple depressed polynomial, and it gives you negative 3. We haven't talked about a graph. That might be a good idea. Now, do you guys understand that nobody's telling you that you can't use Desmos if you're in a bind, or if you...
So when you get to the bottom, how do you tell that it's just going to be x plus 3? Like
So,
how does that work?
Okay, so it has to do with what I started with, degree 3, and then how many times did I divide. What that actually does is lowers this exponent by the amount of divides. So it lowers it 2 times.
So the highest exponent minus the number of times.
Exactly. So this would now be x to the first power, to the first power. So again, you could use Desmos. Nobody's sort of saying you can't, but I want you to be able to understand that what you did here is really sufficient for you to be able to think about a graph that goes up because it's positive, up to the right, and opposite to the left. So you basically have a graph that goes up and down. It's not much to it because these imaginary numbers don't show up. By the way, the y-intercept is another little check. So that's a good sign. If you type that in Desmos, it might be curved a little differently. But I'm just checking that you basically draw the behavior correctly. Well, I know this is good for you. Maybe you disagree, but it's good for you to just use the blank side of this. Again, that's fine. I'll just grab it. It's good for you to get one of these worked out. And I'd like to make this the last thing we do today. I want you to walk out of here thinking one more time about how to process one of these problems in this little exit ticket.